My name is Gabriel and welcome to this exam revision session on the log-normal model of share prices. Now, before you start with your revision, I would like you to carefully read these instructions. So pause the recording, read this, then when you're done, continue with your revision. Now, before I start with this revision, there's something I want to clear, which is extremely important, and I think most people are missing. Now, let's find our page here where we can work. Oh gosh, I'm trying to find my space, the correct space for this. Sorry. Okay, let's work here. Now, from your notes, let me throw in a timeline here, and let me call this time U, and let me call this time T. Obviously, you can see here T is greater than U. Now, from your note, you know that the natural log of ST minus the natural log of SU has a normal distribution with mean mu into T minus S and variance sigma squared into T minus S. Now, what your exam report don't actually show is what I'm about to show you here. Now, if you look here, this is what we call the log-normal model of share prices, right? Share prices or security prices, okay? Now, what they don't show you is what I'm about to show you here. Because if you look at this expression here, so please, every time they say log-normal model, please think about this. Now, here, what we can actually do, we can say the natural log ST, and we can take this side so that we can have the natural log SU plus a normal distribution with mean mu into T minus S and variance sigma squared into T minus S. Now, if you push this inside the normal distribution, do you agree with me that the only thing that will be affected is your mean? So the natural log of ST will actually be a normal distribution with mean ln S of SU plus mu into T minus S and variance sigma squared T minus S. Now, I want ST on its own. So I want the distribution of the share price at this point. So what am I going to do now? Now, I've been explaining this throughout the revision because this is quite common throughout this exam, which is CM2. I'm going to take an exponential on both sides here. And if I take the exponential of the normal distribution, the resulting distribution will be log normal. So that means S sub T is log normal with mean the natural log of SU plus mu into T minus S and variance sigma squared into T minus S. Now, I'm going to find the expected value of the share price. So let's see our timeline. I'm going to find the expected value of the share price at time T and the variance of the share price at time T using these parameters. So this is your mean and this is your variance. Okay, now remember, in general, from your orange book, if a random variable x is a log normal distribution with mean mu and sigma squared, then the expected value of x is equal to e to the power mu plus a half sigma squared. Now, this mu is coming from this parameter and this sigma is coming from this parameter. So if I have ST being log normally distributed with these parameters, then the expected value of ST will be e to the power mu. Mu for the distribution of ST is this yellow expression here. So it's natural log SU plus mu into t minus s, right? Plus half your sigma squared for the distribution of ST is this expression here in orange. So I'm going to have sigma squared into t minus s. Now, sure, I can simplify this because if you look carefully here, what do I have? I have E. Now, I can separate this because remember, if you have got the same base and different exponent and you're multiplying, you can add the exponent, and the opposite is true. So I can say this is the same as the ln of SE to the power of the natural log of SU multiplied by e to the power of mu into t minus s. And I'm going to add the rest because there's no need to separate it. So half sigma squared t minus s. Now, do you agree with me that this will just cancel and I will be left with SU multiplied by e to the power mu into t minus s plus a half sigma squared into t minus x being equal to the expected value of ST. Now, this is actually what they usually show in your exam papers without knowing where it is coming from. So, the expected value at time t, which is the end of the period, is given by this expression, which you know because you've been practicing it and you have been seeing this. So I was showing you this in case you forget it. So let's do it for the variance and see what will happen. So if I've got S sub t as a log normal distribution, then the variance of S sub t, remember the variance in general of x, if we have a normal distribution, is actually equal to e to the power 2 mu plus sigma squared into e to the power of sigma squared minus 1. So for ST with the following parameters shown here, I'm going to have e to the power 2. Your mu is the ln SU plus mu into t minus s, okay? Plus your sigma squared for ST, which is sigma squared into t minus s, into e to the power of sigma squared for the distribution of ST, that is sigma squared into t minus s minus 1. Now I'm going to simplify this. I'm going to perform a little bit of algebra, but it's no big deal for you because you've been doing mathematics for your life. So what am I going to have here? I'm going to have I'm going to separate this as I did previously. E to the power of 2 natural log SU multiplied by e to the power 2 mu into t minus s plus sigma squared into t minus s multiplied by e into sigma squared t minus s minus 1. Now, I'm going to perform a little trick here. Now, please remember, I'm not sure if you can remember this. Remember that if we have the natural log of a to the power b, this is equivalent to b natural log of a. So you can take the a and bring it down. The opposite is true. If we have this, we can take this b and take it up there. So what I'm actually going to do here, I'm going to take this 2 and put it up there. Since we have the natural log, I can do that. So let me go back to my pen. What I'm actually going to have here, I'm going to have e to the power of natural log of su squared multiplied by e to the power 2 mu into t minus s plus sigma squared into t minus x, all that multiplied by e to the power of sigma squared into t minus s minus 1. Now, what am I going to have here? You can see, using your rules, this will cancel, this will come down to su squared e to the power 2 mu into t minus x plus sigma squared into t minus s, all that multiplied by e to the power of sigma squared t minus s minus 1. And this is the expression you will usually see in your exam report. This is where they usually start writing. Now this is the variance of S sub t. So it is the variance of the share price. It is the variance of the share price at this particular point here. It is the variance of the share price at this point. Now, why am I showing you this? You're saying, oh, Gabriel, why are you showing this? Now, this is extremely important because the model becomes easy when your u is equal to 0. So when this u is equal to 0, the model becomes easy. But the moment I'm changing this u to, maybe I'm starting at time 3, and I'm interested in the future, maybe at time 7, then we might have problems there on how to write down the expected value of the share price at time 7 and the expected value and the variance of the share price at time 7. So this is the derivation of your expected value in general from the initial time u to the final time t, and this is the variance for the initial time u and a final time t. So this is where you will always come to. So obviously this is coming from this results here, from the general case of the log normal model. Okay, so in case you forget it in the exam, you know what to do, or the examiner decide to be a little bit naughty and not start at time 3, then you know what to do. Okay, so now you know that. Let's dive straight to our exam revision questions. Now our first question here is taken from the September 2018 exam paper. Now let's read it carefully. They say an investor has £100 and is considering investing into two different stocks. The prices of both stocks are assumed to follow the log normal model with the parameters below. So that is quite important. The prices of both stocks are assumed to follow a log normal model. Straight away, you're going to recall this. The moment you hear the word log normal model, straight away, this is what you must recall. But usually they don't start here. Usually they don't start here, because if you start here, you waste time. But they start here and here. So, but let's read what the question is saying. So I'm giving the parameters for stock A and the parameters for stock B. Now our first question here says calculate the expected value at time 3 of 100 invested in stock A for part A of the question, and 100 invested in stock B for part B of the question. So for part A, I'm looking for the expected value. Now, let me quickly have my papers here. Now, if I'm looking for the expected value given the initial share price and given that the share prices come from the log normal model. You know that the expected value is given by, so the expected value of SA at time what? They said at time 3. So at time 3 is equal to, now I'm going to use the general case here, so please don't get confused. I'm going to start off with the general case. Now the expected value is S sub U, but this is S0, right? S0, e to the power mu, I'm giving t minus s, your final time is 3 and your initial time is 0. So this will just be 3 minus 0, which is 3, plus half into sigma squared into 3 minus 0. Okay, so what am I going to have here? So using this formula in orange, I'm going to have, so it's part what? Part A of the part 1A of the question. So I'm going to have S0 e to the power of mu, but for the log normal model, you know that we have mu into 3 minus 0 plus a half sigma into 3 minus 0. Remember, your t here is 3 and your initial time u is 0. So I invested £100 in stock A, so I'm going to have 100 e to the power. Your mu for stock A is given in the question. It is 0.05. 0.05, but don't forget to multiply by 3, plus a half. Your sigma squared for stock A is given here to be 0.2, but I have to square that. So 0.2 multiplied by 3. From here, there's no problem. You've got your calculator. You straight away punch this in your calculator. And you're going to get the value of 123.37. Now that's your A. Your B, we have to do the same thing, but for stock B. So I'm going to have the expected value of SB at time 3 being equal to S naught, I'm investing 100. E to the power of mu. Now our mu for stock B, if you look carefully here at in your question, is 0.08 or 8%. So that is what I'm going to substitute. 0.08 multiplied by 3. Remember, 3 minus 0. Your 3 is t and your 0 is your u. Your final time minus your initial time. Plus your half sigma squared. Now your sigma for your stock B is 30%, which is 0.3. So I'm going to have multiplied by 0.3, and I'm going to multiply this by 3. Don't forget to square. Now you're going to straight away punch that in your calculator, and you're going to get an answer of £145.50 for stock B. So that is your expected value. No thinking was involved here. I was just applying equation star, which is here. Now let's look at our second question here. Our second question here says, calculate the standard deviation at time 3 of £100 invested in stock A and stock B. Now they're looking for the standard deviation, but you know, you've been studying, we can't go straight away from the standard deviation. We must start from the variance. So this is exactly where I'm going to start. Now this is a log normal model. Now I'm going to use this equation here for the standard deviation. Remember the one I derived earlier. I'm going to call this equation lambda. I'm going to use equation lambda here. So I'll quickly jot it down and I'm going to discuss with you. I'm going to jot equation lambda down and I'm going to discuss the substitution with you. Now, if I jot it down, I have in general. So this is part 2. So in general, we have the variance of S sub t, which is the final time, being equal to the price initially all squared e to the power 2 mu into t minus s plus sigma squared into t minus s multiplied by e to the power sigma squared into t minus s minus 1. Now we are given the initial share price. We are investing £100 at time 0, which means your S is 0. Our final time is 3, so it's final minus initial. You are given a mu for stock B. Our final time is 3 and our initial time is 0. Final time 3 and our initial time is 0. It's always final time minus the initial time. So applying this to stock A, what am I going to have? I'm going to have the variance of stock A at time 3 being equal to the initial share price, which is 100, but don't forget to square that. And I'm going to multiply this by E to the power of 2 times your mu for stock A is, you are given in the question, is 5%, which is 0.05. I'm going to have 0.05, and don't forget to multiply by 3 this part here. Is this part here. Final minus initial. Time is always the tricky part of these types of questions. Now, I'm going to add there your sigma squared, and your sigma for stock A is 0.2. I'm going to square that, multiply by your time. Final time minus the initial time, whatever you'll be given on the day of the examination. And I'm going to multiply this by E to the power of 0.2 squared, multiply by T minus S. Final time minus initial time times 3, and I'm going to subtract 1. Now, you have got your lovely Casio. You'll be sitting with your lovely Casio calculator. From here, you will have to punch this straight away to your calculator. Now, if you punch it, you're going to get 1940.45306. Now, if you round off, because we're dealing with money here, and money is cents, which is it's pence, which is into 2 decimal places, we're going to have 1940.45. So I'm rounding off to 2 decimal places. Now, don't forget to always ask yourself if you've answered the question. The examiner is looking for the standard deviation. Now, you can't stop there, because from your variance, you're going to get the square root. You're going to square root your answer. So the standard deviation of B at time 3 will just be the square root of this. And you're going to get 44.05. Now I'm going to do the same thing here without wasting any time. I'm going to do the same thing for stock B. So the variance at time 3 for stock B, it's the same thing. The only difference is your parameter. So I won't explain the thing here. I'll just substitute the numbers. So 100 squared e to the power of 2 times 0.08 multiplied by 3 plus 0.3 all squared multiplied by 3 into e to the power of 0.3 squared times 3 minus 1. And again, this is calculator work. From here, you have to punch this in your calculator. Now, if you punch this in your calculator, you're going to get 6561.9474. But this is the variance. The examiner, they're looking for the standard deviation. So from there, you're straight away going to take your square root. So your standard deviation at time 3 of B is the square root of this, at which point you're going to get 81.01. Okay, so that wasn't very difficult. It's just the application of your log normal model formulas. As long as you remember them, I don't think you'll have a problem in the examination. Now, if we proceed with this question here, you will see they go straight on to another section, which we're going to discuss later. Now, they go straight to something called portfolio theory. Now, this revision is not for portfolio theory. We have got a revision session on portfolio theory, but because this question included it, we're going to do it anyways. So they say here the investor decide to invest £50 in each stock, so that A and B. Now the first part here says calculate the expected value of the investor's portfolio at time 3. Now this is portfolio theory because they are talking about the portfolio and they're looking for the expected value. Now you know that, and even more easy here, we have got two stocks. So our expression for the expected value and the variance won't be difficult. So you know in general that the expected value of any portfolio is the proportion invested in A multiplied by the expected value of A plus the proportion invested in B multiplied by the expected value of B. Obviously, if we had three stocks, we're going to have plus the proportion invested in C multiplied by the expected value of C. But here we have got two stocks, so the expected value of our portfolio will have two terms. Now this is what you're always going to use when we are asked to calculate the expected value of your of a portfolio. The key word, you must read your question, it must be a portfolio in order for you to apply this particular formula. So remember, this is your proportion here. Is your proportion invested in A, and this is your proportion invested in B. Now, if I invest 50 in each of the stock, now proportion is like your total. So if I'm saying to you, you wrote your actual exam and you got 20 out of 100, and you got 20. Sorry, if I'm saying to you, you wrote your actual exam, which was out of 100, and you got 20, and I asked you what is your proportion. Your proportion will be what you got divided by the total. If I'm saying you wrote your physics exam and you got 5 out of 50, so your proportion will be 5 out of 50. So coming here, trying to explain here, if I'm investing 50 in each, that means I have a total of 100, which means that the proportion invested in A will be £50 over 100, which is 0.5. So I'm going to have 0.5 times the expected value of A, which you calculated in part 1 of the question, which is 123.37 plus your proportion in B. I'm investing 50 in stock A and 50 in stock B. So your proportion in stock B will be 50, but I've got a total of 100. So your proportion will be 50 over 100, which is 0.5. So I'm going to say 0.5 multiplied by the expected value of B, which is, you calculated in part 1 of the question, it is 145.50. Now this is just 1 mark. You're going to punch this in your calculator and you're going to get 134.44. Now they go on into something here. Now let me separate this here. Now they are saying the correlation between the two stock is 0.3. Now they are talking about your correlation. Now I want you to remember from your subject CT3. Sorry. Now I want you to remember from your subject CT3. Oh gosh, it's no longer CT3, it is CS1. So I want you to remember from your subject CS1, I want you to recall that the correlation coefficient between A and B, and is it the correlation I'm given? Yes, it is a correlation. The correlation between A and B is equal to the covariance of A and B divided by the square root of the variance of A multiplied by the variance of B. This is from subject CS1, or commonly known as CT3. Now, if you arrange this, your covariance of A and B will be equal to your correlation coefficient of A and B. Now, if you now remember, the square root of AB is equal to the square root of A multiplied by the square root of B back when you were young in high school. Now I'm going to take the square root separate, the square root of A multiplied by the square root of B, which is going to give me the standard deviation because I'm taking the square root of the variance. So I'm going to have the standard deviation of A multiplied by the standard deviation of B. Now, why am I doing this? Now, well, you will see now why I'm doing it. Because now I'm giving the correlation and the examiners are asking me to calculate the standard deviation. Now this is portfolio theory. This is not part of the section which is covered in your log normal model, but for some reasons the examiner incorporated it here, but you don't have to worry. Now they say calculate the standard deviation. Now note the key word here, we have portfolio at time 3. Now time doesn't matter for portfolio theory. Now you recall your formula from your portfolio theory that the variance of your portfolio, now we have got a general expression for this. A general expression for this is a double summation xi, xj, cij. Now I'm going to explain this when we're doing portfolio theory. How is it useful and why it will be a good idea to remember this in the exam. But because here we've got two portfolio, our expression for the variance is not supposed to be hard because we have got two of them. You're just supposed to recall it. Your variance of your portfolio will be the proportion invested in A squared multiplied by the variance of A plus the proportion invested in B squared multiplied by your variance of B plus 2 times the proportion invested in stock A times the proportion invested in stock B times the covariance of A and B. Now I'm going to show you when we're doing portfolio theory exam revision how to derive the variance for a portfolio for n or 3 or 4 or 5 number of stocks. Here it wasn't so difficult, you just had to recall it for 2 stocks. It's not difficult. Now from here you just substitute your numbers. So your proportion invested in A will be, so I'm using this formula here. Let me go down. Now this video is now longer than I expected, but let me quickly finish this and I'm going to stop it. Now the variance of your portfolio is XA squared VA plus XB squared VB plus 2XA XB covariance of A and B. Now we have got this to be not 0.5. Remember I discussed it, why not 0.5, excuse me. Squared, the variance of A, you calculated it in part 1 of the question. It is 1940, it was part 2, sorry, plus 0.5 squared proportion in B multiplied by the variance of B, which was 6561.94 plus 2 0.5 multiplied by 0.5. Now we don't have the covariance, but we've got this relationship here, which is the correlation coefficient times the standard deviation of A and B. Remember I showed you. So your correlation coefficient is 0.3. The standard deviation of A, you calculated it, is 44.05 multiplied by the standard deviation of B is 81.01. You punch this whole thing. Now this is calculator work here. You don't have to worry. Now if you punch this whole thing in your calculator, you're going to get 2661.03. But you go back and you read your question very carefully. The examiner was looking for the standard deviation. So you have to take your square root. Don't forget. So taking the square root of this, I'm going to get the standard deviation of my portfolio. So taking the square root, I'm going to get 51.59. And there is your standard deviation of your portfolio. Now, this question is a little bit demanding because they take the log normal model and they mixing with portfolio theory. As long as you remember what to do, then you'll be fine. Now, the last part of this question is actually where you are required to comment about your answer. So let me